Good afternoon, everyone. Thank you so much for joining our panel today. So I'm really excited to be moderating what's going to be a very exciting discussion. So as we saw in the intro that Nino graciously gave, we have three very different companies here, and they're all working in areas that are very unique across the EV and battery supply chain. What they have in common, though, is that they're all working towards an innovative new solution that's going to be coming to the EV market. And for each, it has different implications. So for one, it's the basis of a brand new company. It's a startup. They're introducing a new technology to the market. For two others, they're established companies. They have offerings, but they are bringing new offerings to the EV market and capitalizing on the opportunity around the advancement of electrification in our province and in our country. So what I'm hoping that we can take away from the panel today is two things. One is to better get to know these companies, the journeys that they're taking in terms of bringing their technologies to market and understanding what are some of their strategies, what challenges have they faced, what are some of the lessons learned they've had along the way, because I think that conversation is very applicable to other companies that are looking to break into that EV supply chain, again, as it's transitioning. I think the other is to basically shed light on the bigger picture. So as our country is moving from internal combustion engine vehicles to electrification, zero-emission vehicles, what does that mean? Kind of gives us a glimpse of how our ecosystem is changing, what kind of efforts and supports we need to undertake to reinforce the work that we're doing in our country to maintain that leadership in auto and mobility. And so it's going to come with different implications around innovations, new customers, new product offerings, and things like that. So it'll be great for us to have an understanding of what that looks like. So let's get started. Thank you all for being here. And what I'm going to do is ask you, just to start, maybe you can spend a couple of minutes talking about your role within your respective organizations and talk to us a bit about what this innovative product offering is, this next generation manufacturing product that you guys are all working on. So we'll start with Sean at Cyclic. So you guys are building a whole new company around recycling of rare earths. So tell us more about that.
Yeah, so at Cyclic, we are recovering rare earth elements from end-of-life vehicle components, such as the motors that are contained in electric vehicles and hybrid electric vehicles. These rare earths are utilized in the permanent magnets that are contained in these motors, and they're essential to the high efficiencies that electric drivetrains can obtain. We recover these elements through a two-stage process, that first one being a physical separation, where we use an automated system to break down the motors, separate out the metals into copper, aluminum, and steel. Magnets stick to steel because steel is magnetic. We have a technology that's able to extract that rare earth magnet from the steel stream and concentrate it into its own mag extract stream is what we call it. At that physical separation stage, we sell off the copper, aluminum, and steel as scrap metal through traditional recycling routes, but then we take that magnet extract and send it to our second stage process, which is a hydrometallurgical refining stage where we are able to produce high quality rare earth oxides that can be reintroduced in the magnet supply chain and go back into new EVs. My role specifically is looking at closed loop partnerships with OEMs. So how do we leverage their current recycling structures to guide this rare earth containing material to our recycling process, extract the magnets and extract the rare earth, and then figure out how to reintroduce these rare earth oxides back into their supply chain such that they can have their own circular economy. In terms of progress, where we're at, last year in April we raised $27 million in our Series A, which is led by BMW I Ventures and Energy Impact Partners. Since then, we finished piloting our technology and we've deployed our first demo scale facility in Kingston, Ontario, which processes 8,000 tons per year of motors. And then more recently, we were listed on the Cleantech 100 list for 2024, and we're also recognized as the 2024 Early Stage Company of the Year by the Cleantech Group.
Fantastic. Oh, congratulations on that. And I'm excited to delve into a little bit more about what that process looked like. So Rick, Linamar is obviously a major Canadian Tier 1 automotive supplier. And you guys are in the process of developing a facility in Welland, Ontario, focused on gigacasting. So with this facility coming online next year, I believe it is, you guys will be the first Tier 1 in North America to do something like this. So that's really exciting. Why don't you tell us a little bit more about it?
Sure. Yeah, well, Linamar's commitment to electrification automotive didn't start with Gigacasting. There was a e-axle division that was started about 10 years ago. More recently, there was a e-Lin group that was formed to be an overall umbrella all over electrification efforts. And then most recently, a new group was formed that I'm the director of engineering for. It's called Linamar Structures. And that basically took all of Linamar's casting assets globally, along with assets from 2 recently acquired businesses, which I was actually a part of one of the acquisitions, and combined them under this unified group that's focusing on automotive structures, which will include castings, various types of castings, including gigacasting, of course, but also extrusion, fabrication, and manufacturing of battery enclosures. So that's the latest structural organizational change. With this new structures group, as you mentioned, the first gigacasting machine will be installed in the new Welland facility. Currently, we're actually doing process development on a sister machine, a very large die casting machine, at our tech center in France. And the development work is being done there. And then when the Welland plant is ready to come online, the work will be transferred from France to Canada.
That's really exciting stuff. Mark, Novonix has also been around for a little while. You guys have had some battery offerings in the ecosystem, but now you've got a new dry cathode production process. So can you tell us a bit about that?
Yeah, sure. So let's take a quick step back. For those who don't know about Novonix, we are a company that consists of essentially 2 divisions, one in the US focusing on synthetic graphite production, and our Canadian division, Battery Technology Solutions, in which I'm a part of, focuses on delivering equipment, materials, and essentially technology solutions for the whole global lithium-ion battery supply chain, or value chain, rather. My group particularly focuses on this novel method of producing traditional cathode active material. In particular, we're focusing on single crystal NMC style material for its high performance properties. We're actually producing the material on our recently commissioned pilot line back in July of 23, and that has a nameplate capacity of 10 tons per year. So the process itself is patent pending, and we're currently sampling to a variety of cathode producers, cell vendors, and OEMs today for essentially the evaluation and possible adoption of this new all-dry, zero-waste processing technology to create something that the world has used since the early 2000s, NMC. We're just generating it in a more sustainable, lower cost, and improved environmental footprint methodology. So yeah, that's me.
Okay, well, all really great examples of innovation in our country. So fantastic to hear this. And so now that we have an understanding of what these innovative process technologies are, when we talk about taking it to market, let's start with securing customers. So Mark, maybe we can continue with you. You just talked about some of the conversations you're having with OEMs and others. When you look at these new processes, and you mentioned that it's lower cost, better environmental footprint, are you still exploring conversations with the traditional customers that you've worked with? Are you going through different channels? What does that application look like?
Yeah, there's a few different routes to look at if you are a junior startup or coming up with a different process technology. And it's first you can knock on the door and hope somebody answers. We at Novonix have the ability to leverage some of the prior engagements and relationships that we've built over the past decade since the company has started back in 2013. So, for example, some names in the industry would have come to us for our R&D services work, cell prototyping and manufacturing of essentially testing different variants of materials, electrolyte, or that kind of thing. We can then leverage that conversation and keep it going to include our cathode materials and the processing technology to really introduce that new method, this new way of thinking of making materials to whomever that contact essentially is. So that's the route we're taking. I know not everyone can actually go that way unless you have a somewhat established company with a footprint and customers already, but it's a little, we're very fortunate to be able to go that route rather than knock on the door and hope somebody answers.
Yeah, I can imagine that's a lot harder. And Sean, we'll talk to you about that. Mark, Rick, from your perspective, as I understand it, for this gigacasting factory, Linamar does have a customer. You can't disclose who that is. But talk to us a bit about what that process looked like in terms of securing customers and identifying where you could play, with who you could play as far as the gigacasting way goes. Did you leverage some of your existing contacts?
Sure. Yeah. Probably a little bit different scenario than my colleagues here is that gigacasting is effectively ultra-large die casting, which has been around for many, many, many years. One of the most popular light metals casting processes. So Tesla started the process effectively, or pushed the limits of what was possible in die casting. However, with Linamar already having substantial casting assets, including experience in high tonnage die casting at our Mills River, North Carolina facility, a little bit different situation. The OEMs, when Linamar made the commitment in a partnership with this OEM, effectively it caught a lot of attention because that was a big step for Linamar to be the first tier one automotive supplier to invest in this type of technology. Previously, it had been only limited to the OEMs themselves. So the interest from the OEMs is flowing in now, different OEMs for potential future investment. So unlike Mark, we don't have to go around knock on doors. Doors are knocked on a lot for us because of the fact that we're the first tier one to invest in this technology.
Yeah, that's great. I mean, there's something to be said for being a first and to have that market position to be able to enable that. That's great. So Sean, I know, again, it's a little bit different for you. You guys are a startup. So how do you start these conversations with potential customers and show the value proposition of your unique process?
Yeah, so we have a new process, but we're also in a kind of a new industry as well. No one's really recycled rare earths in any significant or meaningful way ever. And so our approach right now is a lot of education. It's making sure everyone knows that this is a problem you have, or it's a problem you will have. This is a problem maybe you don't know about yet. But then also looking at it from their perspective and saying, well, this is a new thing I have to now deal with. That sounds like a burden. So using maybe some recycling structures they put in place, leveraging current schema that they have is really critical for us. I think the battery recycling industry the last 5 years have really developed circular economy teams within the auto groups. And as such, targeting those sectors within the large OEMs is critical for us. I think additionally, with that, figuring out what their overall supply chain looks like is important to figure out how we can insert ourselves to show that we are a partner that's reliable and trustworthy and can actually fit into what they're doing today, so they don't have to do too much more than what they're already doing in this current EV shift. I think that's probably the most important pathway right now for us.
Yeah, that makes a lot of sense. So you're obviously all working at different stages of maturity, all with the goal of kind of bringing your solutions to market and hoping to scale up. So you talked about the relationship with customers, and I think part of that is working together on optimizing your offering, your solution, and to make sure that it remains competitive and it remains sustainable, obviously with that long-term view in mind. So Rick, maybe we can start with you. I think, with Linamar, it sounds like there's a lot of this kind of simultaneous engineering of kind of working with your customer. And so can you talk us through that? How does that compare with traditional casting? And maybe you can also talk about where do tier twos come into play?
Sure, yeah. So I think we probably all heard the term simultaneous engineering. It's a little bit of a catchphrase and has been for quite some time. Effectively, it just means close collaboration with your customer, and rather than taking a more series, step-by-step process to developing and launching a product, it's effectively designing the product, the process, the tooling, the equipment, all relatively simultaneously and in cooperation with your customer. I've seen great examples of it, and I've seen very poor examples of it, because rarely do you hear a customer saying that they don't want to work collaboratively with a supplier. But in this case with gigacasting, although it's not a new technology, it's really stretching the boundaries of what's possible in die casting. And so in this case, In fact, I was at our tech center in France just 2 or 3 weeks ago, and the term is not being abused in this case. It is a very, very collaborative working relationship with our automotive customer. They have on-site people, and literally our engineering team and their engineering team are working through issues truly simultaneously and in cooperation and collaboration, because there is no plan B. Effectively, if this doesn't successfully launch on time, the vehicle will not make it to market on time. So it's truly a collaborative approach that is very refreshing.
I can imagine. And so how does that compare to what you've traditionally done with the casting? Has it not been like that?
In some cases it is. If it's more of a commoditized type product, there's much less of that collaboration. It's much more of a supplier versus customer relationship. And typically the tiers of the supply chain are not really brought into the process. But in this case, the equipment manufacturer, the primary tooling supplier, Linamar, and the end customer are working very closely together.
Yeah, I mean, that is refreshing and probably speaks to like a more modernized kind of way of how we look at continuing to iterate our processes going forward. So Mark, I guess the same question, and maybe you can speak to some of the specific challenges around battery materials. And it sounds like there are some bespoke requirements of your customers. So how do you work together on that to optimize your product?
Yeah, battery materials are very interesting. In fact, a battery will not work unless you have a proper cathode and anode material in there. We'd love to say that battery materials are a commodity. I think Eric from Novonix mentioned this in the last panel, that they're working to have maybe 1 or 2 materials to meet a cell supplier OEM specifications. The cathode space is very similar. You can't just slap together a bunch of metals and hope that you can give it to an OEM and they'll slap it in a battery and say, wow, this is amazing, because it rarely ever is. The cell requirement for the battery that goes into an electric vehicle is going to be extraordinarily specific to the end application, the end use of what that vehicle needs to do. So to get there, the material needs to do whatever the EV is supposed to do. So OEMs, cell manufacturers have very stringent requirements on every material that goes into that battery. So how do we do it? How do we work together? Really, you're forming strategic partnerships with the material manufacturers, the cell suppliers, the OEMs, to come together and understand the specifications of what makes the perfect NMC. And understanding, oh, well, maybe the surface area needs to be a little different. Like, these are the examples of these metrics. It gets very granular, and you have to employ all the tools in your back pocket to essentially create a material that the end user will want to use in their application. So how do you get to that point? Well, step 1 is, I'll use the door knocking example. First, you need to let the OEM, the cell vendor, the material manufacturer know you exist. Okay? Step 2 is prove that your technology, your new material that you're making, or your new process to make an old material actually works. So that gets them interested. You send a sample, they test it, and give you some feedback. And then the third step is really to work together to make that material back and forth. It's an iterative process. Monthly calls are had, maybe in some cases even weekly calls, to really drive towards making that perfect NMC material, or perfect graphite, or perfect silicon to slap into a battery cell that will eventually go into a vehicle. So it's quite a relationship.
Yeah, that does seem like quite a relationship, but obviously the benefits are there at the end of the day.
Correct.
So it's worth the effort. That makes sense. And so, Sean, again, I know it's very different for you. You guys are just starting to have the conversations with customers. You talked a lot about education and awareness in terms of the applications, especially with the auto sector. So talk to us about how you guys envision working with your future customers. Do you think that there will be bespoke requirements? Do you envision kind of that iterative process of supporting them on their particular needs? Or do you think it would be a little bit more broad than that?
I'd say all of the above, but I think maybe just to echo what Rick and Mark have been saying, collaboration is sort of key with this all. the OEMs are end users of these raw materials, but again, there's still lots of stages beforehand that gets them to a point where they are usable in their cars. And so at our stage, we're the kind of end of their supply chain and the beginning. We're tying the knot to make sure it's a loop. And so working with them to figure out, one, on the recycling side, how do we aggregate that material and recycle it and recover it, as well as working with their partners and them to ensure that it's efficiently inserted back into the supply chain such that it's usable directly to them is really key. And so, yeah, I think collaboration is the main way that we move forward strategically on that, yeah.
Yeah, that makes a lot of sense. Okay, and so again, we've talked about securing customer. We've talked about how we make our product innovative and make sure it stays relevant to the industry. Let's talk about what it takes to kind of support deployment of the technology and kind of scaling in the marketplace. So Sean, I'll continue with you. You talked about the funding which you received, which is great. So it sounds like it's going to help you move beyond your pilot plant. Can you talk a bit about some of those deployment plans to actually proliferate some of your technology?
Yeah, so our current deployment plans is we're using a spoke and hub model for our recycling technology, so that first physical separation would be a spoke and the hydromet would be a hub. The idea of a spoke and hub is you deploy these physical smaller plants that only do some mechanical separation locally to where the waste sources are, where they then concentrate the material you're looking for us, it's that magnet extract, which then send to a centralized hub or hydrometallurgical facility where you're able to access the economies of scale. And so currently we're building out our first spoke hub network throughout North America. We plan on expanding into the US this year in addition to our Kingston facility, and we plan on actually increasing the capacity of our Kingston facility as well.
That's fantastic. Mark, same question. So maybe you can speak to a bit about your plans for scaling. What does piloting and deployment kind of look like on your side?
Yeah, so there are two main aspects. One is to ensure that you're making a product that works. This is the science aspect, and you can make a material work in a lab very easily, but the next step up is the midpoint, the engineering side. How do you engineer that that material behaves very well at scale? So then you need to go into either an engineering study or jump right into a pilot demonstration line. So we took that route. So our 10-ton line essentially is an R&D tool to show off the flexibility of our material and to demonstrate that we know how to make a variety of different compositions in the NMC sector that people would find interesting. It's all about gaining that interest with the end user to then later devote to a scaled up version of that material at mass. Biggest challenge is financing, and I think we're going to talk about that a little later, but one of the biggest aspects to anyone who's scaling any technology is financing, and it's a big challenge. And how do you understand how to go from that pilot 10-ton demonstration line to a multi-thousand-ton line is the challenge, and I don't have a particularly good answer for that today. Ask me next year, and I may.
I hope so. But yeah, you're right. That is one of the biggest challenges that we're seeing. Like through OVIN, I can say we work with companies, and that's where they kind of get stuck. I think we generate a lot of great IP and ideas in the province and in our country, but to be able to take that and actually commercialize it and to be able to scale it, I think that takes a lot of effort, and we will talk about what some of those supports are. But Rick, can you maybe talk to us a bit as well? It might be a bit different with the gigacasting and kind of how you scale up, but talk to us about some of the equipment and tooling required with that and kind of how you're going to take that to the next phase.
Okay, sure. Yeah, the scaling, I guess, to simplify it, I'd say there's two main buckets or challenges. One is commercial/timing, and the second is technical. And what I mean by that is the commercial negotiations and negotiation of a contract with a customer to kick things off has to move along at a pretty good rate, because the lead time, there's zero open capacity for gigacasting anywhere in the world. Everything is made to order. The capital is very expensive, the tooling is very expensive, and so it all starts with a commercial agreement with a customer. And the equipment can be a year plus lead time. The tooling can be over 6 months lead time. That's before you can even start making first shots. And then you have process development and qualification and preparation for production. So the first challenge is really commercialization or a commercial agreement with a customer and getting things kicked off just by nature of the length of the development cycle. The second kind of bucket or category of critical things for scaling up is the technical challenges. As I mentioned before, gigacasting is not new, but like almost any process, as you scale up the physical size of the equipment, there's additional challenges. So we've invested a lot in hiring additional people that have strong experience in die casting, in addition to the folks we already had. We've invested a lot in CAE, or computer-aided engineering, and I should say advanced computer-aided engineering, that allows us to do effectively what we call virtual development. So we can do simulation, literally hundreds and hundreds of loops of electronic computer-aided engineering simulations to model what we expect to see when we start casting product. And that helps really reduce the lead time and help us to scale up quicker.
That's great. You touched on a really important point, which I want to delve into a bit more with our panelists. So obviously, it's one thing to have an innovative technology, work towards bringing it to market, but as we scale, we're going to need to make sure that we have the right skills and talent in place to be able to support that. So you talked a bit about your hiring strategy, but maybe you can delve into it a little bit more while we're still with you, Rick. Just talk to us about how you identified what those skills are and where do you find that talent? Because increasingly, we are having a talent shortage here, especially as we grow our supply chain. It's becoming competitive. So how do you deal with that?
Hire early and often. So, for instance, we started the hiring to support the Welland plant well before there was a physical need. And so we have resources that were hired that will be full-time in the Welland Gigacasting facility that have been working in France for months, and it'll be years by the time the Welland plant launches. We have close partnerships with professional organizations, also NADCA, AFS. We've invested a lot of money into advanced computer-aided engineering tools, and we also leverage the time difference between North America and Europe, giving us the ability to have, effectively like a 16-hour workday. So we have computer-aided engineering resources that are working in North America and in Europe to do these simulations. That helps a lot. Linamar also has a very good internship program to attract new talent. So there's no silver bullet to the resource issue. It's pulling in a lot of different resources and a lot of different angles to help find the talent that we need to.
Yeah, makes sense. And so, Sean, same question for you. I know, again, it's a little bit different with a startup. How do you acquire the talent and start thinking about the talent you need as you will scale? Because, again, you guys are pretty early stage, but at some point, presumably, you're going to need some of those capabilities.
Yeah, so I think one thing to note of why we chose Kingston as our first location is because there's such historic knowledge on the mining and chemicals industries over there. As much as we're a recycler, we do go all the way to a commodity grade material in the end, and so it's more akin to mining. Some people call recycling urban mining. So the fact that that talent exists in Canada is really essential to us, and it's one of the reasons why we've been able to be so successful today. I think going forward, as we expand into the US, as we expand to Europe and the rest of the world, that's when the question comes up, as this industry is quite new in general, from EVs, not only just recycling, but EVs in general. And so there's not as much historic knowledge in various regions. However, the only benefit that we do have being on the startup and being in this forefront of technology is you get a lot of people who are very passionate about what they want to do and what they do. And so being able to identify the people who are passionate to try to make a difference here is really key, because you know that they'll always show up and put their best foot forward and the biggest effort in.
Absolutely. Passion is definitely one of those key job requirements, I would say, especially in this industry. And so, Mark, same question for you. Tell us a bit about your talent acquisition strategy, let's call it.
So people capital is very, very interesting. And if you asked me the exact same question last year, which I did answer at the EVIT event, I stood up on the hill and said, we need people in the space, hire, 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 right? Over the past year, I think I've changed my tune a little bit, and I'll talk a little bit about what that means. So when you're scaling to make EV products, batteries, again, this is the lens of a material scientist here. Manufacturing is a very translatable skill. And Ontario, for example, has a fantastic foundation for manufacturing. It's still people limited, and it's kind of stealing from other places to fill the gaps that are present. When you look a little bit more holistically at what's driving these changes, these discoveries, these transformational technologies to improve lithium-ion batteries that go into the EVs, that's where things get a little tricky. For us at Novonix, being a Halifax, Nova Scotia-based company, we're very fortunate to have feeder programs by tapping into the local universities. So Dalhousie University, for example, has a fantastic lithium-ion battery program. There are multiple researchers, Professor Jeff Dawn's group, the Mark Obervac group, the Lucas Swan group, and this is a fantastic avenue for us because typically the students want to stay in Nova Scotia. So these are the type of folks who are driving these discoveries, especially at Novonix as well as the other battery tech companies that are in the local area. People are flocking to Nova Scotia for batteries, and it's an awesome thing to see based off of a lot of things. The pipeline is right there for people, and the people capital is there. What's the next step? Scaling and manufacturing. So there's a few different facets to the problem, and right now I think we're, at least for me personally, I'm not as bad off as I thought I was a year ago. A lot of the training happens organically, and this is what I love to see. We hire folks at a university who have an interest in energy storage, batteries. They don't know a whole lot of the fundamentals, but you know what? We train them, and they develop those skills organically. They don't have the 10-year experience that some folks may require, but they get there. They get there eventually.
Yeah, those are great insights. And I think you all kind of touched on the same things, but it's interesting to talk about moving quickly on talent and looking at how we can harness our regional strengths, because you're right, there are certain capabilities within regions that we can tap into, and then working closely with our post-secondary institutions. So earlier, Mark had spoken about funding. So I'm curious from all of your perspectives, and again, given that you're at different stages, what kind of supports have you leaned on? Because obviously, as an organization, you can do what you can, but it's valuable to work with other infrastructure and resources and supports that can help you get to where you're trying to go as far as the market goes. And so maybe, Sean, we can start with you. I know funding has been really instrumental in helping you guys get off the ground with your deployment. So what supports have you leaned on?
So in addition to the money we raised last year in our Series A, we've also received money through the STTC here in Canada to help scale up our technology, which is incredibly helpful. In addition to that, I mean, we're looking to raise more money, obviously, to further expand, but other supports have been a lot of, recycling associations have been helpful for us to get introduced to many different people within the industry, as well as associations in various verticals, as much as this is all focused on automotive. For us, there are sectors outside of automotive that contain rare earths that we recycle, so wind turbines are a big thing for us as well, and so getting involved in wind turbine associations to understand that complex industry as well, and get to know everyone and all the players there. So finding industry associations has been very critical for us as well to get our name out there, get our foot in the door, and start moving. Yeah.
That makes sense. Rick, I know it's a little bit different from your perspective again, because at the end of the day, a small startup is not going to have the same resources as a major tier one supplier. That said, you still probably lean on some support. So what is it that Linamar might look to be able to support this gigacasting work that you're doing?
Yeah, well, of course, with Linamar being a sizable tier one automotive supplier already, we had the cash flow to be able to fund this first project, but it wasn't without in-depth, tough negotiations with the customer because the capital intensity is very high for something like this. So fortunately, Linamar was in a position to be the first tier one automotive supplier to invest in gigacasting, but also the business case with the customer has to be very, very strong. It has to be a very high volume, financially viable vehicle that would justify this type of investment for both the customer to commit to Linamar and for Linamar to commit to the capital. So.
Yeah. And Mark, from your perspective, you did mention funding.
So R&D is expensive. Any kind of support is helpful to, I guess, proliferate new ideas, new ways of thinking, new manufacturing methods, new materials. And in North America, you have two government supports. You have the USA, if you're going to go there, or in Canada. And it's important for Canadians and Canadian funding entities to be as competitive as they can. Understandably, we're a smaller population, but it's critical to get ideas off the ground, to transfer going from a lab scale to a pilot scale to, again, manufacturing. For us, we've leveraged NRC IRAP funding, NGen funding, among others, and it's absolutely critical for us to get to where we were to where we are today. And it's important to ensure that you are investing in your human capital and also your equipment, again, because R&D is expensive. So it's a challenge. It's a challenge, and need to make sure that the money is placed in the right spot. What I see right now, and I know the previous panel touched on this as well, in Canada, there's a lot of emphasis on downstream funding, cell manufacturing. Upstream, there's also some funding. That middle stream, that midstream section, it does get a little muddy because you need one and the other. To make a cathode plant, it costs money, but you can stand a cathode plant up in 3 to 5 years, whereas a mine takes, what, a decade? So where do you put those funds, and how do you choose? It becomes challenging, and I have no envy for the government to try to set up these policies to figure out where the cash is supposed to go and who and how. It's challenging, but it's a very important piece of the puzzle.
Yeah, absolutely. And to your point, it can be difficult to navigate some of these opportunities, but there are a lot of programs out there. I will plug, if you're an Ontario-based company, we have the Ontario Vehicle Innovation Network supporting technology development and deployment. Obviously, NGen, sponsor for the conference today, they've got great programs from a federal perspective. The Ontario Automotive Modernization Program and many others. So if anyone wants to chat more about those in the room that is looking for funding, please do connect with me. So we have a couple more minutes. I'm going to ask one more question, and then I'm going to give it to the audience to ask any questions. So again, you guys have shared a lot of insights into the journey that your respective companies are going through. I think this is really enlightening, especially for companies in the room who are looking to do the same. So if you can just reflect back on that journey, everything that you've kind of gone through, the successes that you've seen, the challenges, what's one lesson that you would kind of take away and want to impart on an organization who's kind of in a similar position? Sean, I'll start with you.
Yeah, I think stay nimble as a company. I think the last 5 years, the technology in EVs has evolved more rapidly than the automotive industry has probably ever seen with anything. And as such, their needs then change as well. And so as we at Cyclic scale up our technology and our operations, understanding what those changing needs are for our partners is critical for our success. In addition to that, being able to pace ourselves in line with the market is also critical. If you overbuild, you'll end up running out of money. If you underbuild, you won't get market share. So understanding where the need is, when the need is absolutely critical to be able to scale up a technology like ours.
Yeah, that's great advice. Rick?
Again, a little different scenario than my colleagues on the stage here, but I think one thing that's really critical with Gigacasting is, as much as practical upfront, carefully negotiate the statement of requirements, roles and responsibilities. And many of us have probably heard the term RACIC, or which is a tool to help develop or clarify who's responsible for what. With your internal team and with your customers, I think it's really critical to iron that out as much as practical up front, because whenever you're launching a new process that's a new territory, there's going to be many things that come up that you couldn't have even conceived. So the better planning of roles, responsibilities, shared responsibilities up front, the more you're positioning yourself for success.
Yep. And Mark?
Be bold, because you need to be. That's the biggest take-home lesson that I've learned setting up this new process to make cathode materials. You can have a great idea and a great invention, but the scalability of that technology needs to be examined very carefully. The all-dry zero-waste process that we've developed doesn't use traditional feedstock precursor materials. We're not using nickel sulfate, manganese sulfate, cobalt sulfate to make our NMCs. We really like nickel powder, nickel oxide, all the other oxides and metal powders, as well as carbonates to make our material. So for us, know your supply chain and know where you're going to get the materials that go into your materials, because the value add portion is very important.
That's great advice. Okay, I will open it up to the audience. Are there any questions for our panelists? Go ahead.
Very good discussion and congratulations to the panel. Rick, you talk a lot about simulation, right? I represent a company, my name is Fernando. It's a global company on virtual reality simulation labs. I think Mona actually knows us, Virtualware. Do you have in France actual replication, virtual reality simulation, or is physical simulation of your process?
So the question, and I'll just repeat it, is whether in your facility in France you have actual simulation or it's a replica to be able to demonstrate your capabilities?
No, we have product and process simulation capabilities both in North America and in Europe. Our European team focuses more on various forms of process simulation, including casting flow, casting solidification allows us to establish the process parameters for the die casting process. We also have process modeling that enables us to predict distortion and dimensional accuracy. So our European team is primarily, but not exclusively, focused on process simulation. And then on the North America team, we have process simulation also, but in addition to that, we have capability to completely take a black box design from a customer that would basically just give us packaging space, load performance characteristics. Then we have simulation and product engineering tools that allow us to do the actual structural analysis and develop the product also. So it's both.
Thank you. Maybe going on just one more with the virtual reality. Let's talk about immersive training, right? So we have now a huge need of skilled workers, skilled trade workers coming into the EV market, right? For any of you three, you see as well the need to create a specific, even the government should be really stepping in, honestly, not to give to the private, right? To have actually the opportunity to replicate virtual reality labs, not to do immersive training, right? For all these skilled trades. What is your feeling about that? Any of you?
So yeah, the question is any feelings on immersive training using virtual reality to support skills training?
Well, we don't currently utilize any training like that, but however, something that we have that's maybe a step in that direction, it's more focused on our material handling, process handling. There's software packages that enable us to take a 3D model of an entire manufacturing cell. And so when we're designing the automation for that cell, you can use basically a 3D environment to design the robot, the material handling, all of the movements, and program it all effectively virtually before the equipment arrives. And that effectively serves as a really, really good training tool for automation engineers and then automation technicians that would be on the floor troubleshooting, like if a piece of automation goes down. So we're using that. It's not quite what you're asking, but it is maybe a small step in that direction.
Thank you.
Any other questions from our audience? Well, I want to thank all of our panelists for a really engaging discussion. I think you guys have all been very candid with your challenges and the opportunities in bringing your technologies to market. It's not an easy feat, and so I applaud all of the progress that each one of you has made. I think all of us can kind of take away, especially those that are kind of in a similar position with a new process and opportunity to bring it to market. I think as a country, collectively, we've obviously seen a lot of investment. We've seen over 38 billion of investments around EVs and batteries in our country. And so there's an imperative on us to be able to harness that opportunity. And those investments are going to have ripple effects and going to enhance our supply chain. And it's opportunities where companies are coming with new and innovative opportunities, and startups are coming to play in the automotive and EV space to be able to say, yes, come into the fold, and it's up to us to be able to support them and to be able to see them through to bring their innovative technologies to market and to scale them. So something to keep in mind, in terms of collaboration and opportunities. But I thank you all for your insights, and I'm sure that they'd be willing to answer any questions after the fact. And I know that we have our next panel. I see Flavio in the audience. We're going to be talking about Project Arrow 2.0. And I think that Project Arrow really does underscore, again, some of the Canadian capabilities that we've seen with our companies, their innovative technologies, and what it means, and how we can demonstrate on a global platform what it is that Canada is able to do. So lots of excitement on that front. But thank you again to our panelists. Thanks, everyone.